Hey guys, welcome back to another video, and today we're going to be solving the Leet code question, maximum difference between node and ancestor. Alright, so given the root of a binary tree, find the maximum value b for which there exist different nodes a and b. So where b is equal to the absolute difference between the a value and the b's node's value. And over here, the condition is that a is an ancestor of b. So let's first understand what does an ancestor mean. So a node A is an ancestor of B if either any child of A is equal to B or any child of A is an ancestor of B. Okay, so what exactly does that mean? So real quickly, so let's say we have 8 and 3. Okay, so in this case, 8 would be considered as an ancestor of 3. Okay, so now let's actually go to what the question is asking. So in the question, we have a value v, and we want to find out what the maximum v value we can get is. So in the v value, we have a node A. We're going to take its value and subtract it with the node B. And we're going to be taking the absolute value of that. And in this case, like we said, A is an ancestor of B. All right, so let's just see how this is going to look like for this example. So one thing I want to clarify is if you look at example 1, so the tree which they gave over here as the example is a binary search tree. But just because this one over here is a binary search tree doesn't mean that everything is a binary search tree, okay? So just to clarify that our question is for a given tree-based data structure. It is not necessarily going to be a binary search tree, okay? All right, so now that we have that, let's just look at this, okay? So over here, what could one combination be? So one of the values for our v could be the absolute value between 8 minus 3. So does that make sense? Let's just take a look. So 8 is going to be a, and let's say b is equal to 3. So in this case, a has to be an ancestor of b, and that makes sense. 8 is an ancestor of 3. Okay, so that does make sense. So that is a possible answer. That is a possible value that we have. So let's just look at other possibilities. We could have 8 minus 6, okay? So in that case, we would have a value of, well, 8 minus 6 gives us a value of 2. So we would have a v value of 2. Another option is 3 minus 6. That would give us a value of 3. And that's because we're taking the absolute value. So in that case, in this case, actually the best answer would be when we get 8 minus 1. And that gives us a value of 7, and that is going to be what we end up returning. But now let's kind of look at why can't the answer be 13 and 1, right? Because technically that would give us the highest difference, right? So 13 minus 1 would give us a difference of 12. So that should technically be the highest. But what you need to realize is that in this case, A is an ancestor of B, right? But that is not the case. 1 is not a child of 13, so that is not going to be a correct answer in this case, okay? So in that case, so that is why 8 and 1 are the perfect two nodes. So 8 minus 1 gives us 7, and that's our answer. And that also makes sense because, well, 1 is a child of 8. All right, so hopefully you understood what the question is asking for, and now let's just see how we can solve it. Okay, so over here, we have the same we have the same tree, and what we're going to be doing here is we'll see how we can solve this question. So what's going to happen is at each point, we're going to have a minimum value and a maximum value, okay? So what we're going to basically be trying to find out is, okay, so the question that we kind of need to ask ourselves is, when do we have the largest difference? So it's basically when we have the maximum value and the minimum value. So since we want to kind of follow the condition of the ancestor thing that we had, what we're going to do is we're only going to look for the maximum and minimum as we go down that certain route, okay? So what exactly does that mean? And one more thing we're going to have is we're going to have a variable called the result, and this over here is going to be a global variable, right? So each time what we're going to be doing, this is going to have the v value, okay? And we're going to be updating it with the largest v value we currently have. So this is how it's going to work. So at the first head node, so in the very beginning, the root node I mean, we have 8. So at 8, the minimum and maximum is going to be 8 itself, okay? And that's what we're going to end up starting off with, okay? So 8 and 8. Now what we're going to do is, let's find out what the difference is. So in this case, the difference will be 8 minus 8, which is, well, 0. And since we don't even really have anything else to compare it with, in the very beginning, our result is just going to be 0. Okay, perfect. So now let's go on to the next step. So now we're going to be iterating over to the left. So when we go to the left, currently the minimum and maximum are still 8 and 8. But what we need to do is we want to update that with the current node that we are on. So in this case, the current node that we are on is 3. But before we actually update our value, what we're going to do is we're going to calculate for our maximum or the v value, right? So in this case, what are the possibilities for our v value? So for our v value, we have two possibilities. So in this case, what we're going to do, one possibility is either going to be the minimum value subtracted by whatever current value we're on, okay? So that's one thing we have. And the other thing that we could do is we could take the maximum value and subtract that with the current value we have. So in this case, we're going to be taking the absolute value for both of these, okay? So now let's just calculate it. So in this case, it will be h minus 3, and the other option is also h minus 3. So in both the cases, you get a value of 5. Now what we're going to do is we're going to go to our result. So in this case, we're going to compare our previous result with each of these values. So we have 0, 5, and 5. So between the three of them, what is the largest? Well, it's 5. So that is going to be our result. So our result now has a value of 5. Okay, so hopefully you understood what happened, but let's just kind of go through it more and you'll understand. Okay, so now we need to update the minimum and maximum values to the root node 3. Okay, so for 3, we're going to check if between 3 and 8. So 3 is less than 8, so that is going to be the new min value. And 3 and 8, well, for maximum, 8 is bigger, so 8 is going to stay the same. So since we changed our minimum value, what we're going to do is we're going to kind of update that for that certain node that we have. So in this case, the minimum is going to be 3 and the maximum is going to be 8 for the node 3. So now we're going to go on to the left again. So now we're currently at 1. So now we're going to do the exact same steps. So over here, we're going to check for the v value. So the v value could either be 3 minus 1, giving us a value of 2, or we could have 8 minus 1, giving us a value of 7. So now we're going to update our result. So in this case, our result can either be 5, 2, or 7. Well, we're going to choose the maximum, which in this case is going to be 7, so the value gets replaced. So now to the left of 1, we don't have anything, but we're going to update these values over here before that. So in this case, for 1, the values that we would actually have for the minimum would actually be, well, the minimum is now going to be 1, and the maximum over here is going to be 8. Okay, but when you go to the left of 1, there is nothing, right? So 1 does not have any children. It's a leaf node. So in that case, we're going to go all the way back up to 3. So since we're going back to 3, the minimum and maximum values get a change to whatever we're currently on. So now it's going to stay as 3, 8, okay? So we have that, and now we're going to go to the right, which is 6. So hopefully you understand what we're doing, and I'll just go through it one or two more times so you can kind of fully understand it, okay? So now we have the number 6. So we're going to check, does 6 fit over here or here? Well, no. So 8 is bigger than 6, and 3 is less than 6, so it stays as it is. So in this case, now let's calculate the v value. So it's either going to be 3 minus 6, okay? So 3 minus 6 gives us a value of negative 3, but absolute value gives us 3. And then and the other option is 8 minus 6, giving us 2. Well, both of these options, 3 and 2, are less than whatever our current result is, which is 7. So nothing's going to happen, and we just keep moving on. And the minimum and maximum values are also not going to change, so they stay as it is, 3, 8. Okay, so now we go on to the left of this, so we're at 4 currently, and we're going to do the same things. And again, well, 4 doesn't actually fit anywhere because 4 is in between 3 and 8, so nothing's actually going to end up happening. Node 4 is going to have the values of 3, 8. Right now we're at 7, so we're going to look at its left and right children. It doesn't have anything, so that means we're currently done with this entire left subtree. So what that means is we're going to go all the way back to our 8. So now that we're going back to our 8, our minimum and maximum values are 3 and 8. But that's not correct because 3 over here, so let's say now we go to 10, okay? So when you go to 10, 3 is not a child of 10. So that's not a proper value, right? So now what's going to happen is we're going to update or change the minimum and maximum values to whatever was in the beginning over here, which is 8, 8. So now the minimum is going to be 8 and maximum is going to be 8. And we're just going to repeat the entire same process or steps. If you really understood what was happening, I'm sure you can kind of identify how this is a recursive case. So each time we're going to have a function where we're going to be passing in the minimum and maximum values for that specific node. We're going to be going to the left as long as we can. And once we reach a leaf, we're going to go back to the root node and we're going to go to the right. So hopefully you understood what we're going to be doing, kind of. And now let's see what a solution to this is going to look like. All right, so over here, let's just start off with the very first base case is we're going to check if we actually have a value for our root. So if not root, then in that case, we can just directly end up returning 0 because the v value is just going to be 0. And okay, yeah, so we got that. And now what we want to do is we want to kind of establish the variable result that we were talking about. And remember that this over here is going to be a global variable, right? So in that case, what we're going to do is we're going to do self.result, right? So it's going to be an attribute of our class solution. And that is going to be starting off at a value of 0. All right. So now what we're going to do is we're going to go down. And over here, we're going to have our recursive function that we are going to be calling. So this function over here, let's just call it helper function. And what is it going to take? So it's going to take 3 parameters. So the first parameter is going to be what node are we currently on. All right, so let's just call this current node, okay? Or just current. All right, now we're going to have what is the current maximum of or at that certain node, right? So that is basically this value over here, which is 8,8, right? So that's a current minimum and maximum at the node 8. So let's say we go to 3, the current minimum and maximum are 3,8. So that's what we're going to be keeping track of. So let's just call that current min. And the other thing is going to be current max. All right. Okay, so the first thing that we're actually going to end up doing inside of our function is we're going to update our result, right? So that's exactly what we did. So over here, we're going to go to self.result. And over here, we need to update it. So how exactly are we going to do that? So to do that, we're going to be taking the maximum between whatever the old result was. So that's going to be self.result. And we have 2 other options. So one of the options is we're going to take the absolute value between whatever our current maximum is, and we're going to subtract that with whatever node we are currently on, its value. So to do that, we're going to do current.val. So that's one option. And the other option we have, I'll just copy this over actually. And instead of subtracting with the current maximum, we're going to subtract it with the current minimum. So cur_min. Okay, so those over there are our 2 options, and we're going to choose the maximum of that. So now we have a new updated self.result. So now we need to update the max and minimums for that specific root node. Okay, so to do that, what we're going to do is we're going to update them. So current_min. So what is the current min over here going to be? So that over here is going to be the minimum between the old value, so current_min, that's the old value, and the current node that we are on, since the current node could be a minimum. So to get that, we can just do current.val. So we take the minimum between those 2, and I'm pretty sure you guessed it, for the maximum, it's the exact same thing, except instead of minimum, you take the maximum. All right, so I'll just change that. So current_max. And instead of minimum, we will be taking the maximum between current_max and current.val. Okay, perfect. So now we have our updated values, and now all we need to do is we need to call this function on itself recursively. So to do that, our function is called helper. So we're calling the helper function over here, and we need to give it the same parameters. So we're going to be going to the left first. So node. So cur.left, and to that we're going to give it the current maximum value, or sorry, the current minimum value first, so current_min, and then the current maximum value. All right, so now we're going to do the exact same thing, but after this we're going to call it for our right node, okay? So in this case, what's going to happen is we're going to go inside of this function over here until we reach an ending. But technically, as we look at our function right now, there is no end to it. So how exactly do we end it? So to kind of have an ending point, what we're going to do is we're going to check if our current node actually has a value. So if it doesn't have a value, what that means is that, so we're at 1, and if you go to the left of 1, we go over here. And this over here has a value of none. So in that case, what we can do is we can just stop our function. So to do that, all we're going to do is we're going to check if not current. So if current does not have a value, then in that case, we can just directly return, right? We're just going to exit it. We're going to stop. Okay, so that's what's going to happen. And yeah, so that's all we need to do. And finally, all we need to do is we want to call the function for the first time. So the first time when we're calling it, we're going to call our helper function. and we're going to give it the root as the current node, and the minimum and maximum are going to be the value of the root. Right, so if you look at our previous example, we started off at 8 as the minimum and the maximum. So root.val for the minimum and root.val for the maximum. All right, so we called our function, and at the ending, our self.result should have the answer inside of it. And that's exactly what we're going to end up returning. So return self.result. Let's submit this and let's see what happens. And as you can see, our submission did get accepted. So finally, thanks a lot for watching, guys. Do let me know if you have any questions, and don't forget to like and subscribe. Thank you.